Hi, I'm Sharad. I'm going to walk you through some examples of the k-means algorithm. So just to recap, the steps involved in k-means are to initialize k centroids randomly in our dataset. Then we assign all points in our data to their closest centroid. Then we calculate new centroids for each cluster by taking the average of all data points. So in a way, this will update our centroids and give us new clusters, and then we repeat the above two steps until there are no changes in the position of the centroids. So let's have a sample data set. So the image on the right is consists of all the data points in our data set represented by the green dots. Then we initialize k equal to 2 centroids. So we create two centroids marked with a red cross and with a blue cross. The next step is to assign all points in our data set to their closest cluster. So it would lead to something like this, where the red points belong to the red cluster and the blue points belong to the blue cluster. The next step would be to then calculate the new centroid by taking the average of all data points in our cluster. So this way we would update the position of our centroid to its newer position as shown in the figure. And then we repeat the above two steps until our centroids don't change anymore. So in figure A, we reassign all points to their closest cluster. Then in figure B, we have calculated a new centroid and again reassigned all data points. And finally, we get to figure C, where we have two distinct clusters, and our centroids are right in the middle of each cluster, and so they won't change anymore if you keep running the algorithm. Finally, we have a real world example of k-means. So k-means is commonly used in image compression, and the idea here is that we want to represent our original image using just k colors. So in this example, we have our original image which has a lot of colors, and then we try to compress it by running k-means algorithm. So we represent the same image with just 8 colors, which leads to a more compressed version of the image. The question I have is, what is one real world application of k-means? The answer is image compression. Thank you.